Multiple choice question number 1.
P-value is probability of A, rejecting null hypothesis when it is false, B, not rejecting null hypothesis when it is false, C, rejecting null hypothesis when it is true, D, not rejecting null hypothesis when it is true, E, accepting the null hypothesis either true or false.
The answer is C. A p-value is the probability of getting the observed results if the null hypothesis is true. It tells us how likely it is that the findings happened by chance. A small p-value, usually less than 0.05, means the results are unlikely due to chance, so we reject the null hypothesis. A large p-value means there isn't enough evidence to reject the null hypothesis. In short, the p-value measures the strength of evidence against the null hypothesis in hypothesis testing. A p-value is calculated under the assumption that the null hypothesis is true. Rejecting the null hypothesis when it is actually true is called a type 1 error, and the p-value reflects the probability of making this kind of error.
Multiple choice question number 2.
Which of the following cannot be drawn from quantitative data? A, bar diagram, B, flowchart, C, scattered diagram, D, pie chart, or E, histogram?
The answer is B. Bar diagram, pie chart, scatter diagram, and histogram are all graphical methods used to represent quantitative data. Bar diagram compares quantities across categories. Pie chart shows proportions of parts to a whole. Scatter diagram shows relationships between two quantitative variables. Histogram displays frequency distributions of numerical data. Flowchart, however, is a diagram representing processes, workflows, or algorithms, and is not used to visualize or summarize quantitative data. It focuses on sequential steps or decision paths rather than numeric data. Thus, a flowchart cannot be drawn to display quantitative data.
Multiple choice question number 3.
Changes in occurrence of influenza over long period of time are known as A, epidemics, B, endemic, C, seasonal trend, D, secular trend, E, cyclical trend.
The answer is D. Changes in the occurrence of influenza over a long period of time are referred to as a secular trend. A secular trend describes long-term patterns or changes in disease occurrence over years or decades. It reflects gradual increases or decreases influenced by factors like immunity, social conditions, and public health interventions. This is different from seasonal trends, which are shorter-term, predictable fluctuations during certain seasons. Epidemics are sudden, sharp increases in cases, while endemic describes constant presence in a population. Cyclical trends show periodic rises and falls over shorter cycles, for example, several years.
Multiple choice question number 4.
In a population of 1,000, the number of new cases of TB are 80 and old cases are 70. What is the prevalence of TB in that population? A, 10%, B, 15%, C, 20%, D, 25%, E, 30%.
Correct answer, B. Prevalence is the proportion of the total number of cases, new and old, in a population at a given time. Given, total population equals 1,000, new cases, or incidence, equals 80, old cases, existing prevalence, equals 70. Prevalence equals new cases plus old cases divided by total population times 100. Prevalence equals 80 plus 70 divided by 1,000 times 100 equals 150 divided by 1,000 times 100 equals 15%. So, the prevalence of TB in the population is 15%.
Multiple choice question number 5.
In a population, the disease occurs 10 times more frequently in women than in men, higher incidence, but the overall number of cases present at a given time, prevalence, is the same in both sexes. What can be inferred from this situation? A. The disease duration is shorter in men than in women. B.
Risk factors causing the disease are more common in women. C. Women have a lower case fatality rate, die less often from the disease. D. Women have a higher case fatality rate, die more often from the disease. E. The disease lasts longer in women than in men.
Correct answer is A. If a disease occurs 10 times more frequently in women than in men, higher incidence, but the total number of cases at a given time, prevalence, is the same in both sexes, it means that the duration of the disease must be shorter in women. This is because prevalence is influenced by both incidence and duration. Prevalence equals incidence times duration. For prevalence to be equal, despite higher incidence in women, women must have shorter disease durations due to faster recovery or higher fatality, balancing the numbers. In other words, women may either recover slower or live longer with the disease, resulting in higher prevalence despite an incidence difference. This is consistent with epidemiological principles where prevalence reflects both how often new cases occur and how long cases last.